Um, so in yesterday's lesson, we talked about how the inverse of a power function is yx, right? Um, so to determine the equation of the inverse of a power function, you can just switch x and y and solve for y, right? So there's their work. I want to do this on our own, step by step, okay? So if we started out with y equals x squared, that's what it started out as, right? Right? Okay. Okay, so I just graphed them both on the same set of axes. How did I know that the inverse would be right there? How did I know where to put those red points? Yeah, you just transpose the x and the y. You just switch them. Right. Okay. What points do they have in common? 0, 0, 1, 1. How come? Yeah, they're the same. When you switch it, it doesn't change. They're exactly the same. Exactly. Alright. Look at, see the little box there with the speaking bubble? This graph right here is showing that every positive number has two real square roots, okay? Even though I'm not going to actually find the square root of like 2.5, I know it has two of them, because see, there and there, there and there. They all have two square roots. They have a positive one and a negative one, okay? But when you restrict the domain, which one's the domain, the x and the y? The x, yeah, the domain is the x. These are Algebra 1 questions, by the way. When you restrict the domain to values greater than or equal to 0, the inverse of the function is called the square root function. If I say, okay, we're just looking at positive numbers. Now, do I have a function? Yes, I do. Now it's going to pass the vertical line test. It's called the square root function. And it's written like this. The inverse of f of x equals the square root of x for x being greater than or equal to 0. Very important to restrict it. If I don't restrict it, it's no longer a function. If I let it get down below 0 and start counting those negative numbers, then it's not a function anymore. Okay? So looking at this, if I restrict the domain of the inverse to just positive numbers, which of these points can I use? points will I use when I switch to just talking negative numbers? I mean, just talking positive numbers. 2, 4, this one? Okay. Is that it? Yeah. Can I use this one? Yeah. So basically, that's what I can use. Alright, on page 678, number 5, graph your new square root function after you restrict the domain. If I restrict the domain, my new square root function looks like what? Here, here. What's next? Not 2, 4, 4, 2. 9, 3. Right there. Alright, let's talk about some key characteristics of each function. Alright, now this one is x squared for x being greater than 0. So it's right here. Okay. This one is the square root of x for x being greater than 0. That way. Alright, let's compare. What's the domain on this one? What are my x values here? Positive numbers, right? So it starts at 0 and it goes to infinity, right? What's the range on this one? Again, starts at 0. This could be a hard bracket. And it goes to infinity. What's the x-intercept on this one? 0, 0. What's the y-intercept? 0, 0. Okay, now let's compare it with this one. What's the domain on the inverse? Yep, from 0 to infinity. What's the range? Yes. X-intercept? Y-intercept? Now, question 8 is asking about an asymptote. Remember what an asymptote is? It's that line that it's forever going to get closer and closer and closer and closer to. It's never going to touch it. Does this have an asymptote? Is there a point that it just can't reach? What? Well, that's not an asymptote. It just stops. It's like an asymptote is forever going to get closer and closer and closer and closer. At 0, it's like we slam into a brick wall. There's no getting closer. Like, that's it. You're done. Finished. Okay? So is there a number that it's just going to try to forever get closer to? No, it's really just going to go forever. Yeah. Positive square root increases for infinity. Like, I can always find a number that's bigger that has a square root. So there's no asymptote there. Alright, let's look at cubes now. What's a cube? To what power? Alright, the cube root function here. The cube root function is the inverse of the power function f of x equals x to the third, and can be written as the inverse of f of x is the cube root of x. Alright, so this shows x to the third. On here, graph x to the third and graph the inverse, which is the third root of x. Graph both of them on this. I'll wait. Alright, so does it look something like that? Yeah. These would actually probably spread out a little bit more, but I have those fat markers, so it looks like they're just right on top of each other. But one is curving up, and one is curving down, so they don't actually just sit on top of each other like that. Okay? So just know that. Alright, so how did you graph it? Have to find out what the red one was going to be. Just switch x and y. Yeah. Okay. What points do they have in common? Yeah, they're exactly the same. Anything that's going to be exactly the same is still going to be the same when you switch it. Why do we not have to write the plus or minus for this problem? This one. Why don't we have to write the plus or minus on that one? Right, because it's a cube root, and so that sign doesn't get multiplied out. If it's a negative, it's a negative. If it's a positive, it's a positive. So it doesn't matter if it's positive or negative. We get to use this without any restrictions because it's an invertible function. It doesn't, this is a function, the blue is a function, the red is a function. They're both functions, so it's invertible. Alright, look at number 4. I'm going to keep this up here so we can see a picture. But look at number 4 on the next page. What's the domain of the blue function? All real numbers. Yeah, it goes from negative infinity to positive infinity. What about the range? All real numbers. Yeah. X-intercept? Yep. Y-intercept? Yes. How about the red function? Domain? Yep. Range? Exactly. X-intercept? Yep. Y-intercept? Exactly. Alright. There's a definition at the very bottom of 680. It's important. The inverses of power functions with exponents greater than or equal to 2, such as square root functions and cube root functions, are called radical functions. Radical functions are the inverses of power functions with an exponent greater than 2. Okay, we're going to stop there for today.